limitations of first law of thermodynamics. Now, if we closely observe the various principles introduced by the first law of thermodynamics, now we can identify the various limitations that we can come across in this first law of thermodynamics. Here, the first law of thermodynamics, it has introduced one thermodynamic property called enthalpy. Through this enthalpy change, the first law of thermodynamics explains the spontaneity of the chemical reactions. According to first law of thermodynamics, for any change, if the enthalpy change is negative, the first law of thermodynamics says the reaction is spontaneous. Next, for any change, if the enthalpy change is positive, the first law of thermodynamics says that the reaction is endothermic and the reaction is non-spontaneous. Next, if the enthalpy change is 0, the reaction is neither exothermic nor endothermic, and we cannot predict the spontaneity of those reactions. That means mainly based on the enthalpy change, the first law of thermodynamics explains the spontaneity. So, according to this first law of thermodynamics, the changes in which enthalpy change is negative are spontaneous. The changes in which enthalpy change is positive are endothermic and non-spontaneous. The changes in which enthalpy change is 0, they are neither spontaneous nor non-spontaneous. Next, if you closely observe the various changes that happens in the nature, for example, evaporation of the water. Here, during the evaporation of the water, actually the enthalpy change is positive. Therefore, according to first law of thermodynamics, if you observe the enthalpy change, the first law of thermodynamics says the evaporation of the water should not happen in the nature because its enthalpy change is positive. But evaporation of the water will continuously takes place. Why the evaporation of the water is continuously taking place, we don't get any explanation from first law of thermodynamics. Therefore, in order to explain how the evaporation of water is taking place, if we apply the first law of thermodynamics to study the evaporation of the water, according to first law of thermodynamics, the evaporation of the water should not happen in the nature, because during the evaporation of the water, the enthalpy change is positive. The first law of thermodynamics says that whenever if enthalpy change is positive, those reactions are non-spontaneous. Hence, according to first law of thermodynamics, evaporation of water is non-spontaneous, hence it should not happen in the nature. But evaporation of the water will continuously takes place. How it continuously takes place, why the evaporation of the water is taking place, we don't get any explanation from the first law of thermodynamics. Therefore, this is the first limitation of the first law of thermodynamics. Next, the second limitation of the first law of thermodynamics. See, this first law of thermodynamics, it has studied the work done by the system, work done by the surroundings under different conditions. For example, under one condition, we have maintained the temperature as constant. That means when temperature is maintained constant, that process we have called it as the isothermal process. So, according to first law of thermodynamics, in any isothermal process, the heat that is being exchanged with the surroundings has finally found to be equivalent to work involved in the system or work involved in the surroundings. That means at constant temperature, heat exchange has become equal to work involved. That means dou Q has become finally equal to dou W. So, that means at constant temperature, heat exchanged with the surroundings has become equal to work involved. Next, so this relation is correct mathematically according to first law of thermodynamics, but practically is it possible to maintain the temperature continuously constant during the course of reaction? Practically under normal in any circumstances, it may not be possible to maintain the constant temperature. Therefore, the first law of thermodynamics, it has introduced one process called isothermal process. In that isothermal process, the maximum work involved in the process is equivalent to heat exchange. That is true. But practically, it may not be possible to maintain constant temperature. In that aspect, that will become a limitation of the first law of thermodynamics. Next, the third limitation of the first law of thermodynamics. See, the first law of thermodynamics has introduced one famous statement, that is, heat lost by the system is equal to heat gained by the surroundings, or heat lost by the surroundings is equal to heat gained by the system. That means if one system loses some amount of the heat, the first law of thermodynamics says that same amount of the heat will be gained by the other system. So, So this that heat lost by the system is equal to heat gained by the another system. Is it true or not? So for example, if heat lost by one system is exactly equivalent to heat gained by the another system, then efficiency of every engine, efficiency of every automobile engine must be 100% efficient. But practically in the nature, we don't extract any work to the 100% efficiency. So for example, if you observe the automobile, normal automobile engine, to the maximum extent, we will get the efficiency of 63% only. Now what is happening to the 37% of the fuel? So it is getting wasted. Therefore, the first law of thermodynamics says that the efficiency of the every engine is 100%. But practically, the efficiency of the every engine is not at all 100%. So why the efficiency has become less than 100%? Why it is not able to extract the 100% work from any system? We don't get any explanation from the first law of thermodynamics. Next, another important drawback of the first law of thermodynamics is it has introduced one thermodynamic property called enthalpy change and another thermodynamic property called internal energy change. So with the enthalpy change as well as with the internal energy change, it has tried to explain the spontaneity of the various reactions. But practically, if you observe the various spontaneous reactions, to study the various aspects involved in the spontaneity, in addition to enthalpy change and internal energy change, so many other thermodynamic functions are required. What are the other functions that are required? How they will influence the first law of thermodynamics has not at all studied in depth of the subject. Next drawback is this all principles involved in the first law of thermodynamics, all changes that we study in the first law of thermodynamics are applicable only to the macroscopic systems. That means at the microscopic level, for each and every molecule, if you apply the first law of thermodynamics, we don't get any satisfactory explanation about the changes that are happening based on the first law of thermodynamics. So these are the 5 drawbacks or 5 limitations that we can find inside this first law of thermodynamics. Next, to rectify these defects, to give the explanation for this first law of thermodynamics, another law called second law of thermodynamics was introduced.